Hi, welcome to Sajjan Study Tech. Today topic is quicksort. Quicksort is a sorting algorithm based on divide and conquer that picks the an element as a pivot and partitions the given array around the picked pivot by placing the pivot in its correct position in the sorted array. Now we can take one example, then you can discuss how we can solve that particular problem, how we can sort that elements by using this quicksort. So the time complexity best case and average case is omega of n log n, but worst case is n square. That means already that elements, what are the elements, you can consider that all elements in sorted order, then you can apply the quicksort. So the time complexity is big of n square. Otherwise the time complexity best and average case is n log n. So what is the recurrence relation for this quicksort is same as the merge sort. So in previous video I discussed what is the recurrence relation of the merge sort, that is T of n that is equal to 2t n by 2 plus n. So same recurrence relation you can take here. Okay, if you can watch that previous video, so you can solve this recurrence relation. Now we can take one example. You can call the algorithm of quicksort that array name is A and lower bound and upper bound. If lower bound less than or equal to upper bound, that means more than one element is there. If only one element is there, that element is sorted order, only one element. So need not to do anything. But if that array consisting of more than one element, then you can apply the quicksort. So here it is lower bound less than or equal to upper bound, lower equal to partition of, you can call the partition sort array A and lower bound and upper bound. So now we can discuss the partition. So what it indicates in partition sort here. So now we can see, for example, I am consider these are the elements. Here it is 5 and 3, for example 1, here it is 8, here it is 6, for example here element is 4. So this is the example. So you can sort these elements by using quicksort. So here it is array A, it indicates the lower bound, that starting value is 0 index 0 and 1 and 2 3 and 4 and 5, total 6 elements is there in that array. So lower bound is 0 and upper bound value is 5. Name of the algorithm A here. Pivot equal to A of lower bound, that is pivot of A of lower bound, that is A of 0, that value is 5. So start equal to lower bound and equal to upper bound. So here it indicates the start, here it is indicates the end. Now we can check while start less than n, s start is 0 and is 5, the condition is true. Then while A of start less than or equal to pivot, so what is the A of start value, that is 5. So here it is 5 less than or equal to pivot. What is the pivot element, that is 5. 5 less than or equal to 5, as the condition is true. Then start plus plus, start incremented by 1, start plus plus. So start indicates here. So then here also you can check the same condition, A of start less than or equal to pivot, A of start value is, that value is 3, So 3 less than or equal to, what is the pivot element? Pivot element is 5. So it is also true. Then start plus plus. Now start is incremented by 1. Here it is a start. And also can check A of start. A of start value is 1. So 1 less than or equal to, what is the pivot element? Pivot element is 5. 1 less than or equal to 5. So this condition is also true. Then start incremented. Start incremented. Now the start here. Now the start here. Again you can check A of start less than or equal to pivot. A of start value is 8. Now 8 less than or equal to pivot element 5. Okay, the condition is fail. Now we can stop this. Now we can check this while loop here. A of n greater than end pivot. A of n is, A of n value is 4. So 4 greater than pivot element. What is the pivot element? That is 5. So 4 greater than 5. The condition is fail. Okay, if the condition is true, and minus minus. If the condition is fail, so here also check the condition. Start less than end. Start less than end. Start is, here it is 3. 3 less than 5. The condition is true. Then interchange A of start and A of end. What is the A of start? Here it is, A of start is 8, and interchange A of end here. So I can write here the first element is 5 and 3 and 1. Here I can interchange. Here it is 4 and 6 and 8. Okay, same thing you have to check the same condition here also. Start less than end. Here it is a start. It is a start. It is and. You can check the same condition. A start less than end. Yes, that condition is true. A of start less than or equal to pivot. A of start value is 4. 4 less than or equal to pivot. The pivot element is 5. The condition is true. So here it is, start is incremented. Start is incremented. Now the start is here. And also you can check A of start, that is 6. 6 less than or equal to pivot element. Pivot element is 5. The condition is fail. Now we can check this while loop. A of end greater than pivot. A of end. So what is the A of end? A of end value is 8. 8 greater than pivot, as the condition is true. Then and minus minus. And minus minus. So here it is, and is decremented. And is also indicate here. And is also indicated. Start and end indicates the same position here. Now we can check A of end greater than pivot. A of end value is 6. 6 greater than pivot element, as it is true. Then and minus minus, that is and indicates here, and start indicates here. Start and indicates here. Okay, again you can check A of end value is 4. 4 greater than pivot element is 5. The condition is fail. If the condition is fail, here you can check start less than end. So what is the start value here? For example, here the index is 0 and 1 and 2. Here it is 3 and 4 and 5. Now start is 4. Start is 4 here. 4 less than end. What is the end here? End indicates 3. The condition is fail. So start less than end, the condition is fail. Then swap A of lower bound, A of end. So what is the A of lower bound here? A of lower bound, that is A of lower bound value is 5, and A of end, what is the A of end? It is a 4. So you can swap it. Swap. Now it is, here it is 4, here it is 3 and 1. You can take the 5 here, then 6 is there, 8 is there. So this pivot element, this pivot element is placed in perfect position here. So you can see what are the elements is there in left side. So that is the less than of the pivot. What are the elements is there in right side? That is the greater than to the pivot element. This element. So you can find out the perfect position. You can return this location. Okay, what is this location here? It is 0 and 1 and 2 and 3, 4 and 5. So you can return this location. So again you can apply this partition 1. Here it is a P1. Here I am taking the P2. Here the same thing you can apply quicksort here and here. You can see it can return that return end. So the end value is 3. Now we can see here it can return 3. The 3 is stored here the location. Then quicksort you can apply array A and lower bound, that is 0, and location minus 1, that is location is 3, that is 2, and also here array A and location plus 1, that is 3 plus 1, 4, and up to upper bound. So what is the upper bound here? It is a 5. So same thing you can apply the quicksort again. You can see you can find out the perfect position for this pivot element. Here also you can apply the same thing. Here also you can apply the same thing. For example, here 4 3 1. So I am consider this is the pivot element. Now you can check the same thing. Here it is a start, here it is a end. Okay. So here also you can apply the quicksort. Here it is a start, here it is end. Here the starting element, take the pivot element here. So like that we have to sort this entire list. Here also you can find out, here it is a 5. So in find out the perfect position for this, that is 4 and 3 and 1 is there. Here also you can find out the perfect position. That position is a perfect position for this. Here also only one element is there. Here it is 2 elements is there. Again you can apply the same thing. Here also you can find out the perfect position for these 3. So it is 1 and 3 and 4. Here it is 5 and 6 and 8. So this is the algorithm. This is the example for the quicksort. Thank you for watching this video.